I'm going to help you understand how to find the difference quotient of a function, and that is this expression here. And normally, you will first do this in precalculus, but later on, once you get to calculus 1, you'll see this again because you have to find the derivative by using the definition. But that will be for later on. In this video, we'll go over 3 types of functions that you really have to know. The first type is when we have a polynomial. Here I have a quadratic. And then the second type is when we have a square root function. And then the third type is when we have a rational function. The rational function is the trickiest because there's a very common mistake that students usually make. So be aware of that. I'll point out for you so you don't make that mistake. Let's start with this one first. Here we have f of a plus h minus f of a all over h. Sometimes you will see people use x here and x here. That's fine. All right, if this is the first time you're doing it, I would recommend you to write this down on the side and just focus on that. F of a plus h. This means we put a plus h into this x here and x here. So we have 3 and then a plus h squared and then minus 4 a plus h. Then, whenever we have a polynomial function for the difference quotient like that, keep in mind you are going to expand it and later on combine terms. And then at the end, here's the secret of doing the difference quotient. This h on the bottom will always be cancelled. Alright? Trust me, it will be. For all 3 cases you'll see today. Alright, expand this. I'm going to put this down right here. Here we have the 3. A plus h squared. Remember the expansion formula. We get a squared. And then please remember this part plus 2ah. Right? The middle part plus 2ah. 2 times this and that. Continue plus h squared. Okay. And then for this one, I'm just going to distribute the negative 4. So we get negative 4a and then minus 4h. Now distribute this 3. So we have 3a squared plus 6ah and then plus 6h squared and then the rest. Alright, so that's what f of a plus h will be. So if you come back here, this will give us, first we write down all that to there. 3a squared plus 6ah plus 3h squared and then minus 4a minus 4h. That is for f of a plus h. Next, I will have to figure out what f of a is. Well, for that, f of a, you really don't have to write this down again because you see it's just a matter of look at this function and you change the x to a. You have 3a squared minus 4a. And this is what we have to put right there. But here's the thing though. We are going to subtract this part, which is the f of a, but it has 2 terms. So make sure you put parentheses around it and then let's enter the 3a squared minus 4a. So make sure you have the parentheses because later on we will have to distribute the negative. And then this is all over h. Okay? Again, this right here, it's a common mistake. If you don't have it, again, it's going to be wrong later on. So let's continue. I'm going to distribute the negative, so I will write this down again. 3a squared plus 6ah plus 3h squared minus 4a minus 4h. Negative times that is negative 3a squared and then negative times negative plus 4a all over h. Now, is there anything that we can combine? Yes, the 3a squared minus 3x squared, they cancel to be 0. What else? Minus 4a plus 4a, gone. Now, we have this, and that. We have 3 terms. But more importantly, notice that they all have an h. So we are going to factor that out. This will give us the h in the front. Right here, we took out the h, so we have 6a. Continue, plus 3h to the first power now, because we took one of them out. and then minus 4h right here, but the h is out, so just minus 4. And then as you can see, this is over h. Well, the h is gone now, right? After we canceled it. So the final answer for that is just 6a plus 3h minus 4. Done. All right, quick recap. Make sure you remember the binomial expansion. It will be much easier if you just use the formula. And then the other thing is, make sure when you subtract f of a, if it has two terms like this, put them in your parentheses. And then the final thing is that the h on the bottom will always be gone at the end, just like that. Now let's move down to example 2. Here we have f of x equals square root of x plus 3. For this, f of a plus h, we put this into the x. So square root of a plus h plus 3. And that's the most that we can do. So leave it for now. Secondly, f of a. This is just putting the a right here. So square root of a plus 3. All right. So the expression is this being that square root of a plus h plus 3. And then minus f of a is square root of a plus 3. And then all over h. So that's how it looks like. What do we do next though? In this case, it doesn't quite make sense for us to talk about expanding it, right? So for the square root function case, the key is you are going to multiply the top and bottom by the conjugate. So that is going to be, you put parentheses around it, you change the middle right here, instead of a minus to a plus. That's the conjugate. So multiply the top by square root of a plus h plus 3. And then this is a plus now, you change it, that's the conjugate. And then the other part stays the same. And do the same thing on the bottom. All right, now notice when we do the conjugate, we have a minus b times a plus b, right? And that's the purpose of the conjugate because we will get a difference of two squares. Remember, when we do a minus b times a plus b, this will just give us a squared minus b squared, right? That's the formula. And to take care of this, all we have to do is look at the first term, square that. Square and square root cancel, so just have the input, which is the a plus h plus 3. Then we have to subtract the second term, square. Second term is square root of a plus 3. Square root cancel, so we have the a plus 3 here. Just inside. What am I missing right here? Parentheses, yes, if you tell me parentheses, excellent, because again, it has two terms. So put a parentheses around it. And then over, here's another secret. Remember the secret I told you is that the h will get cancelled later on. So do not multiply it in, leave it. Wait for the h to be cancelled later on. So I'm going to keep it h times square root, all these things, just write it down again. Right. So now, distribute this negative. So we will get a plus h plus 3 minus a minus 3 all over that thing. So I'm going to write this down one more time. Look at the top. What can we do? Yes, a and minus a cancel. 3 and minus 3 cancel. Good. Now we have just h on the top. And we have that h on the bottom. Right here, to save one step, if you look at this and that, because it's h times this quantity, yes, you can cancel this and that. So what do we have on the top though? 1. Because remember the final is a reduction. It's like 2 over 6. Reduce it to 1 over 3, right? So when you cancel the h and h, you have a 1. 1 over just this now. So square root a plus h plus 3 plus square root of a plus 3. Now for the last one, we have a rational function, 3 over 2x plus 1. So let's work out f of a plus h. That's just 3 over 2 times a plus h, and then plus 1. Now notice we have a 2 in front of the parentheses. So let's distribute that. 2a plus 2h, and then plus 1. Then for f of a, it's just 3 over 2a plus 1. Okay, going back here, this expression is that we have 3 over 2a plus 2h plus 1 minus f of a, which is this, 3 over 2a plus 1, and then all over this h. Now, how are we going to take care of this though? Well, here we have a complex fraction or a compound fraction, meaning that we have one little fraction, two little fractions inside of a big one. So in this case, I would recommend you guys to multiply the top and bottom by the least common multiple of the small fractions, which is just this times that. So multiply the top by 2a plus 2h plus 1, and then also the 2a plus 1. And do the same thing on the bottom. Alright, now we will take this, multiply it with that. So have a look. When we do that, this denominator and this will cancel. So we have the 3 right here. And then we will have to multiply with the 2a plus 1. To continue, we have the minus, and then this 3 stays here. And then when we take this times that, the 2a plus 1 cancel, so we have this part. So 2a plus 2h plus 1, okay? And then this is all over, well, you know it, just like earlier, the h will be cancelled later on, so just keep it. Do not multiply in the inside. Now, here is the common mistakes. Right here, a lot of people will just do like, hey, this is 2a plus 1. We also have 2a plus 1. They cancel it out. And then they also cancel this out. And then they just end up with 3 minus 3 over h, which is like 0 over h. No, that doesn't not work. The reason why is because you can blank out this negative. Because imagine if you didn't have that denominator. What would you normally do with that? You would distribute the 3 and then combine terms on the top, right? So we'll do that. So on the top, distribute. I'm emphasizing that we're distributing. We have 6a plus 3. And then take this, multiply that into the parentheses. We have negative 6a minus 6h minus 3. And then all over the denominator. Now, focus on the top. What can we do? Here we have the 6a minus 6a cancel. 3 minus 3 cancel. Aha, what else do we have? This now is negative 6 times h over h times this times that. Notice we have a multiplication. Yeah? This is also h times this times that. So we can cancel this h and this h. That's legitimate. So finally, we have negative 6 on the top over this and that. So 2a plus 2h plus 1 times 2a plus 1. And that's the answer. So hopefully this video helps, and best of luck in your pre-calculus class. That's it.